Okay, so this is 2.3, and it just says launch, but again, 2.3 deals with reflections today. So let's see what this looks like. It says half of the logo is missing. Perform a transformation to complete the other half. And so the 4 transformations we've covered, translation, reflection, rotation, and dilation, we've only done so far one. We did translation so far. So if I was to translate this, it wouldn't look like the McDonald's logo, in case you didn't realize that's kind of where we were headed. Because this portion here, if you translated it, then this part here would match up to this, and that's usually not how the logo looks, where it's kind of like an M, right? And so to continue this is where reflection comes in. This is the newest transformation that we are going to practice. So imagine having a line right here that just like cuts that directly, just right at that half, and that's going to be like your line of reflection. Also, I know a lot of you called it like symmetry or line of symmetry. That's the same idea. So in order to perform this transformation, if we had points, it would obviously make it a lot easier. But since we don't have points, I used some tracing paper. I know you guys don't all have this, but if you want to just do your best sketch, that's fine. So I used the tracing paper and started by tracing an outline of this original little M, right? Then I tried to, instead of just translating, I'm not doing this, I need to flip it. So I'm going to flip my paper and then match it up to where it would have flipped from. As soon as I do that, I'm going to trace this a lot harder on my paper so that it kind of leaves an indent mark, and then that'll help me to be able to draw it out. But you can just do your best sketch. It's okay if it's not perfect, of just imagine what it would look like as you flip it over that line. So something like this. Okay, so you can kind of see it looks like the McDonald's logo now that it's complete. As long as yours kind of looks the same, similar, idea. Doesn't have to be perfect. That's the main idea for this first example. And it says, what transformation did we do? So let's write down that we reflected, or you can use the word flip. Technically, reflection or reflect is the more mathematical term for it. And then flip is just kind of what you're actually actively doing. So we are reflecting or flipping over the vertical line drawn in. So since I drew that line first to show that that's what I'm going to flip over, that's the vertical line we flipped over. Now, whenever we work with vertical and horizontal lines, you did a little bit of this last year and you've done them in middle school, students tend to have trouble writing equations of vertical lines and horizontal lines. So remember, vertical lines are always going to be x equals a number. So this equation, if we knew what number it was sitting at, it would have been like x equals a certain number. We don't know what that number is just yet, but we're going to see a little bit with the examples coming up. Okay, so for our first example, and it does say this is partner work, so I'm going to start by telling you what problem you can work on, and then I'm going to pause it so that you can either try this out yourself or with a partner, someone sitting next to you. And then as you try some of this out, hopefully it's going to start coming to you about how we do reflections with horizontal and vertical lines. Now, I know I used the word over here, like when I said reflect over this line. That's fine to use, or sometimes you're going to see it written as reflection in vertical or horizontal line. So it might say something like, can you reflect triangle JAI in the x-axis? And I know that sounds a little odd, that it should say maybe like over it, but that means the exact same thing. Now we can reflect the triangle over different lines. We could use any kind of vertical line, horizontal line, or the x-axis or the y-axis. I just chose to start with the x-axis, where some of you could try out the x-axis, some could do the y-axis, and we could get an idea of kind of both of them. But there's so many examples possible here. We're just picking one. So again, remember, this is the x-axis. It's the horizontal one. It's at 0. So if I wanted to write an equation for this also, this equation would be y equals 0. So someone could say, can you reflect this triangle over or over the line y equals 0? That would be the same exact thing, that you're flipping it over the x-axis or over this exact equation. Okay, so I'm going to give everyone a few minutes now to try to actually do a reflection. Here's a hint as you're trying to figure out if you're not sure what to do exactly. The reflection of every single, or whenever you have a pre-image, its reflection is always the same distance away to the line of reflection. So if I go up for a second here with the McDonald's, I could pick a point like, let's say, I don't know, here. And if I measure this distance, it's the same distance to get to this point here. And I don't have like an exact ruler or anything to measure it, but like that, I could put the little tick marks to show that those are the same. Same thing if I do one point like all the way out here. This distance to the line of reflection is the same as this distance to the line of reflection. Okay, so same idea here then. As you are graphing out and figuring out how to reflect this, figure out how far away, like start at one point, like letter A, and say I'm going to go down 1 to get to the line of reflection. So once you hit that, then just go one more down, like kind of the same distance away, and then label it A prime. Okay, so go ahead and try this out with J prime and I prime, and then write their coordinates as well. Here's what your image should look like, right? So this is the after the reflection has been done, all you're doing is, again, counting how far from each point until you hit the line of reflection, and then extend it that same number of points. So make sure you're counting carefully, because that's really the only mistakes that could be made would be if you just incorrectly counted too far or something. Same thing with the eye. You go down 2, so you go down 2 more, and then don't forget to label them with the primes, right? And then connect your lines. So there's my reflected image. Then I go and write down both their coordinates. So all I did was just kind of identify what are the coordinates of J, A, and I, and for J prime, A prime, I prime, and wrote them in. So let's try to make some observations. How about the first thing, looking at just the x's? Does anyone see kind of what happened with the x's? They stayed the same. Okay, so these x's each stayed the same every single time. Nothing changed there. What about the y's, though? It went 5 to -5, 1 to -1, 2 to -2. So what's happening there? Anyone see that? Yeah.
The y-axis gets changed to negative.
Yeah, so the y-coordinate just switches signs. Exactly. They switch, or they're opposites. So that's what we're going to write down in words down here and as a coordinate rule. Okay, so kind of similar to what we did yesterday. We're going to still say that the x values stayed the same, and the y values will be opposite. Just meaning that the sign changed. Now specifically, this is for only a reflection over the x-axis. Let me make sure that's clear, that this isn't for every single type of reflection. This is just for any kind of reflection over the x-axis. That's what we will see happen. And we'll see what happens on the next page with for a y-axis as well. It basically just like switches it. That's the main idea here. So for a coordinate rule, though, just like yesterday, remember that we start with the coordinate x comma y, and we're saying keep the x the same, don't switch anything about x, but then make the y an opposite. So opposite would mean put a negative with the y, and that's exactly what happens with each of these y values. They just switch their signs. So that's what we have for the coordinate rule and the verbal explanation. As far as like on a quiz or a test, usually coordinates will be provided if you're trying to come up with a coordinate rule. It won't just say, here's a transformation that happened. Can you tell me the coordinate rule without any coordinates? Because that does make it harder to come up with. So always kind of look at the coordinates and say, okay, what am I observing? Are they staying the same? Are they switching signs? Is it maybe I'm adding a certain number or subtracting a certain number to try to figure out what to do? Okay. Now, all reflections are not going to have this easy of a coordinate rule, and so that's why as they get trickier, we don't always do coordinate rules for every type of reflection that you're going to see most likely on Monday. So for now, let's go to the back page though, and we see a little bit of a summary real quick, and then we'll do one more example down here. Okay, so it says a reflection changes of figures. Like if you think back from yesterday, there was 3 words we used to talk about transformations. That's orientation, position, and size. So specifically today, reflections can change the position because it moves like location of where it's going, and it also changes the orientation. So like if the order of the letters was going in a certain order, like when J first, then A first, then I first, or after that, it switches that up. Okay, that's what orientation means. But it does not change its size. Size does not change based on the reflection. Remember, we're only going to see that later with dilations. Okay, so the coordinate rule we just talked about on the front page was x comma y, and then it did not change the x, but then made the y negative, or opposite. So that's what it looked like for the reflection in the x-axis. Now for the reflection in the y-axis, it's going to look really similar. If you had done this whole problem, and which feel free to do that if you want to go back to the last example with J, A, and I, and just reflect it over the y-axis instead this way, right? If you try seeing what happens, it's going to actually do the opposite of this, where it will make the x negative, right? It'll switch its sign. Doesn't mean that it's always negative. It's just meaning if it was a negative number, you make it positive. If it was a positive number, you make it negative. And the y would stay the same. So it really just kind of switches exactly what happened here with the y-axis. But again, we're not only going to reflect over just the x and just the y-axis. We can reflect over any line. So today, in this example here, we're about to see what happens when we reflect over a different type of line that's not an axis, either a horizontal or vertical one. Today's homework will all focus on just horizontal and vertical lines, but then on Monday we will see what happens when you have just a line that has a different kind of slope. Okay, so first thing we have to make sure we know how to do is, can you identify when a line is horizontal versus vertical? Sometimes there was like a mnemonic device that some people used or some teachers have shown. One of those things is called Vuxhoy. If that helps you, use it. If it doesn't, ignore it. If that's so confusing to you, just don't even worry about this. V stands for vertical, U stands for undefined slope, and X stands for the equation. It's always going to be X equals a number. So whenever you see a vertical line, it's always going to be X equals some number. Okay, so make sure you look at that carefully for homework tonight, because every year we have students that just mix them up. That I know that when you see a vertical line, you're thinking like the y-axis, but that's not right. You need to be thinking x equals a number, because that's when it would form a vertical line. Same thing with the HOY. The H stands for horizontal, so imagine a line like this. The O is actually technically a zero slope, and y is the type of equation again. Y equals a number. So if I see this equation off to the left here, where it says reflect point Q and point P in the line y equals 2, right away I know that that line is horizontal. I need to draw a horizontal line at 2. So please make sure you do that part carefully first, because if the line is drawn wrong, then your whole reflection will be incorrect. So I want to draw the line y equals 2, and feel free to use a highlighter or markers or pens just to make sure you know exactly what the line of reflection is. There's my line of reflection. I'm going to label it here. Okay, reflection. Okay, so now let's go ahead and practice doing the reflection. I'm going to use a different color here. We just have 2 points to move, so this should be pretty straightforward. For the Q, you're going to go down 2 and to hit the line. So then we go down 2 more, and that puts Q prime right on the x-axis. That's okay. Don't forget to put the prime notation. And for P, it starts down, so we have to count up 1, 2, 3, 4, 5. So count 5 more going up, and now we have P prime. Right, so that's what we have for our points here. We have both of the, like we did the reflection, we're done with the first part of the question. Now there's just kind of 2 follow-up questions to this. Now on the homework tonight, you're going to have to probably do more than just points. You'll have figures, so you have to move every single point on the figure the same distance away. Sometimes, like let's imagine, I know there wasn't an example of this, let's say there was a point right here that was called point T. Okay, if someone says, can you reflect point T, you would say, it's already kind of done. You wouldn't be able to move it anywhere up, down, and it would also be the location of T prime. Okay, so if you need that example, because I know it didn't say anything about that, but there's a question on the homework where sometimes the point is just right on the line. You don't move it. You just call it the new name with the notation. But if a point is either above it or below it, you just go in that direction. And it's okay if there's kind of like overlap between the points as well. Okay, so the last two things here says draw a line through each point and its image. Okay, so this is each the point Q and its image is point Q prime. So I need to just draw a line to connect those. And I'll also draw, I'm going to use a ruler, but you can just connect P to P prime like this. Okay, so we're connecting those just right now. I know you're not always going to do this, but just to make some observations, I chose to connect those. So let's see, what do we realize about what conclusions we can draw. So it says, what conclusions can you draw about the line of reflection and the line connecting any point in its image? So does anyone remember what it's called when these two lines intersect like this? What type of lines are these? Yeah, see? Yeah, you got it. It is perpendicular. So I'm going to put the little right angles like that because that's what we know, that they are perpendicular, because when one line is vertical and the other one is horizontal, they have to form a 90-degree angle there, or perpendicular. Okay, so this right here, I'll write down that the two lines are perpendicular. And if you remember the symbol for perpendicular, I'm just going to put that in parentheses. It's that upside down T. Okay, so anytime you have an image and it's pre-image, like the 2 points, and you connect them with a line, it should always be perpendicular to the line of reflection. If it's not, something went wrong with your graph of or where you were making your reflection, because it always will be perpendicular, and you can always check it. Now, because of that, does anyone remember, and this is something from advanced algebra last year, what do the slopes have to be for perpendicular lines? Anyone remember? Yeah. No, not the radical. But it is something that starts with an R, if that's what you're thinking. Anybody remember? So I'm going to start writing it here, and so if it comes to anybody, the slopes, actually I'm going to put in parentheses, are, or would be, okay, I'm going to start it off. The word was opposite. Does anyone remember the rest? Yeah. Yes, thank you. Reciprocal. So opposite reciprocals. That meant where you would, let's say we started with the number 1/2 was the slope of one of the lines, then its opposite reciprocal meant you had to flip the fraction and you had to make an opposite sign. So if one of them was positive, the other one would be negative. Now with vertical and horizontal lines, they do have opposite reciprocal slopes because one of the slopes is 0 and the other one is undefined. And that's because the 0 can't be in the denominator. So vertical and horizontal lines naturally have opposite reciprocal slopes, even though you might not realize it. But we're going to see more with this on Monday with opposite reciprocal slopes. Okay? There's none really with homework. You don't have to really bother with that too much. The last thing, it says, what can you say about the distance from a point to the line of reflection and the distance from the image of that same point to the line of reflection? Okay, so it's kind of wordy, but what it's basically saying is just that each of these points going to the actual line of reflection here, notice that it's equidistant because we counted how far away it was going to go for each of them. So from Q to the line of reflection and from Q prime to the line of reflection. Same for P to the line of reflection and P prime to the line of reflection, right? Each of those are the same. You can put the tick marks if you want to show that, or just that's what we're going to write down here, is that the distance is the same. Or we'll write down in parentheses, the word that we use to explain that is equidistant. Okay, and this is